Welcome to Science Era. In this video, we're going to discuss reaction yields from chapter number 4, section 4.4. We're going to look at concepts like theoretical yield, limiting reactant or reagents, and also percentage yield. Let's begin. Reaction stoichiometry. When reactants are mixed for a chemical reaction, the amounts are rarely mixed in perfect stoichiometric amounts. The limiting reactant will be entirely consumed in a reaction and some amount of excess reactant will be left over. So the reactant or reagent which is entirely consumed is called limiting reactant or reagent, and the leftover is called excess reactant. We use stoichiometry to determine which reactant is limiting before attempting to calculate the yield. We can calculate theoretical yield and percentage yield or amount of product produced. If 6 molecules of H2 reacts with 4 molecules of chlorine, HCl is produced. Which reactant is limiting? When H2 and chlorine are combined in non-stoichiometric amount, one of these reactants will limit the amount of HCl that can be produced. In this illustration, a reaction shows in which hydrogen is present in excess and chlorine is a limiting reagent. We can see that these are the molecules of hydrogen which is present in excess. So therefore H2 is in excess and chlorine is the limiting reagent. Identifying a limiting reactant. Determine the number of moles of each reactant. Use stoichiometry to conduct two trials. Calculate the amount of product formed if the first reactant is consumed completely, and do the same for second reactant if it is consumed completely. The reactant that produces the least amount of product is the limiting reactant, and the reaction yield can be calculated based on the complete consumption of limiting reactants. If 2 moles of H2 reacts with 3 moles of chlorine, HCl is produced. Which reactant is limiting? In order to identify the limiting reactant, we must compare the amount of product expected for complete reaction of each reactant. Each reactant amount is used to separately calculate the amount of product that would be formed per reaction's stoichiometry. The reactant yielding the lesser amount of product will be the limiting reactant. For example, in trial 1, we know that H2 and HCl is present in 1:2 ratio. And we know that 2 moles of H2O is reacting. So 2 moles of H2O times 2 mole of HCl produced over the 1 mole of H2 as per the equation stoichiometry. 4 moles of HCl will be produced. Then you do the same calculation using chlorine. 3 moles of chlorine is reacting to produce HCl, and the chlorine and HCl ratio, stoichiometric ratio according to the equation is 1:2 again. So 3 moles of chlorine times 2 mole of HCl over the 1 mole of Cl2 will give you 6 mole of HCl. We know that using up H2O results in fewer moles of product, so therefore H2 is the limiting reactant and chlorine is in the excess, so it is the excess reactant. So hydrogen will be completely consumed once 4 mole of HCl is produced. Therefore hydrogen is the limiting reactant and chlorine is in the excess. Silicon nitride Si3NO4 is hard temperature resistant ceramic used to make turbine blades for jet engine. Silicon nitride is synthesized by reacting solid silicon with nitrogen gas. What is the limiting reaction when 2 grams of silicon and 1.54 gram of nitrogen gas reacts? So 3Si plus 2N2 will give you Si3N4 silicon nitride. In order to find the limiting reactant, we must first compute the provided molar amount of reactant and then compare the amounts to the balanced equation to identify the limiting reactant. So we know that 2 gram of silicon is given and 1.50 gram of N2 is reacting. So we know how to calculate number of moles from the formula number of moles is equal to mass over molar mass. Mass of silicon and mass of nitrogen is given in the question. So if we calculate the number of moles of silicon first, 2 grams of silicon is react times the 1 mole of silicon over the molar mass, which is 28.09 grams, will give you 0.0712 moles of silicon. Same for nitrogen using the formula mass over molar mass. 1.50 gram of nitrogen over the 28.02 gram of nitrogen, which is the molar mass of nitrogen, will give you 0.0535 moles of nitrogen. After calculating the number of moles for silicon and nitrogen, we know that molar ratio of silicon and nitrogen is 1.33 moles of silicon over 1 mole of nitrogen. So 1.33 is to 1. And from the balanced equation given in the question, we know that stoichiometric ratio of silicon and nitrogen is 1.5 is to 1. If we compare these ratio, it shows that silicon is provided in less than stoichiometric amount, and so it is a limiting reactant in the equation. Other way to solve for the limiting reagent is computes the amount of products expected for complete reaction of each of the provided reactant. So the 0.0712 moles of silicon would yield 0.0237 moles of Si3N4 silicon nitride, and if we see if we look at, while 0.0535 moles of nitrogen would produce 0.0268 mole of silicon nitride. So therefore we can see that silicon yields the lesser amount of product, therefore it is the limiting reactant. Percentage yield: the amount of product that can be produced if everything in a reaction process goes perfectly is theoretical yield, and the amount of product produced when a reaction is carried out in laboratory is actual yield. So percentage yield is equal to actual yield over theoretical yield times 100 to give you percentage yield. Note that we should not confuse a percentage yield with percentage error. Percentage error is actual value minus theoretical value over the theoretical value times 100. Problem solving technique. In order to find the percentage yield, we first need to convert grams of reactant to moles of reactants. If there is more than one reactant, we must find the limiting reactant unless it has been specified. Then convert moles of reactant to grams of product to find the theoretical yield. The theoretical yield is based on the limiting reagent. After that, convert grams of reactant to grams of product, and then you can find out the percentage yield by using the formula actual over theoretical yields times 100%. Next is example. If the reaction of 17.9 grams of oxygen produces 3.10 grams of water, what is the percentage yield? In order to find the percentage yield, we first need to identify the limiting reagent, which is mentioned in the question In this case, it is oxygen. Next, we need to determine the number of moles of limiting reagent. Number of moles we can find out using the formula mass over molar mass, which will give you 17.9 grams of O2 as stated in the question, divided by molar mass of oxygen, which is 32 grams per mole, which will give you 0.56 moles of oxygen. Next is finding out the theoretical yield by using the limiting reagent formula. We can do this by multiplying the number of moles of limiting reagent times the stoichiometric ratio, which in this case is 0.5 or 1:2, times the molar mass of the water, in this case other product, right? So 0.56 times half times 18 will give you 5.04. Depending on what the question is asking for, use one of the equation above to determine the percentage yield or actual yield. In this case, question is asking you to find out the percentage yield. So you're going to divide actual yield, which is 3.10 grams of H2O, over the theoretical yield, which we calculated as 5.04, times 100. In this case, the percentage yield is equal to 61.5%. This brings us to the end of section 4.4 of chapter number 4 from OpenStax Chemistry. Thank you for watching. If you like my video, don't forget to subscribe for more.